Hi there. Week 3 of our course is dedicated to diving into the topic of pumps and material mixing for 3D concrete printing. Today's agenda revolves around the mixers and mixing setups finally designed for this innovative technology. Initially, we'll explore various concrete mixers, such as a drum mixer and pad mixer, before transitioning into the distinct mixing systems designed for 3D concrete printing. These systems typically fall into two main categories, which is batch mixing and continuous mixing systems. Let's start by explaining about the types of concrete mixers. The drum mixer stands out as the most adaptable and extensively used industrial concrete mixer, primarily applied in smaller construction projects or areas limited in equipment access. However, its production capacity relies heavily on the container or the drum size, meaning this could produce large volume of concrete mixture. For instance, larger reversing drum mixers are commonly employed in concrete batching plants, featuring a drum that rotates horizontally or slightly tilted to thoroughly mix concrete components. These mixers are user-friendly and can be mounted on trailers or stationary stands for mobility, offering a practical solution for smaller on-site concrete batches. Moving to the pad mixer, this variety utilizes a stationary mixing pan or like a rotating mixing pan with rotating mixing blades or pedals inside. This setup efficiently mixes dry and wet concrete ingredients, boasting greater mixing power and delivering a consistent, uniform mix. Pan mixers are well suited for projects requiring smaller batch production or producing precast concrete elements due to their moderate capacity and superior mixing performance. Additionally, these mixers can clean quite efficiently between the batches. Lastly, the twin-shaft mixer. This comprises two horizontal shafts inside of the mixing chamber equipped with counter-rotating blades or pedals, effectively blending concrete ingredients. Known for their high efficiency in producing consistent, top-quality concrete mixes, these mixers are preferred for large-scale projects with high concrete volume needs and stringent quality standards. They ensure comprehensive mixing and uniformity, making them ideal for application that demands precise control over the mixing process. The choice of concrete mixer depends on various factors such as a project scale, project capacity, mobility requirements, and desired concrete quality. Truck mixers prove essential for continuous concrete transport in larger projects, while on-site mixers like drum, pan, or twin-shaft mixers find their use in smaller projects or when meticulous control over the mixing process is very crucial. Selecting the right mixer guarantees efficient and effective concrete production tailored to meet the specific demands of the construction project. Those discussed mixers are the most common and readily available mixer types and mechanisms, primarily following a batch mixing process. The batch mixing process setup involves the separation of the mixing station from the pumping station, operating sequentially. Put simply, a batch of concrete mixture is blended in one of those mixers as your choice, and then conveyed to the pump hopper for the 3D concrete printing process. In batch mixing, the process starts with mixing proportioning, which entails weighing defined or predetermined quantities of dry materials, water, chemical additives, and other components. Water is added to the dry materials and blended with mechanical energy to uniformly disperse the dry ingredients, initiating contact between the water and the solids. This aims to uniformly distribute water to cover all solid particles and disperse chemical additives effectively throughout the mixture. Each batch generates a specific volume of concrete, typically mixed for a set or determined duration, generally lasting seconds to minutes to ensure homogeneity before being discharged. Following discharge, the mixture is transported to either the nozzle or end effector if utilized. The final material characteristics are determined by the dosage of chemical additives in the end effector if used. The strength of the batch mixing lies in its flexibility to adjust the mixer design for rheology control or other purposes. Altering the proportioning of dry or the wet constituents is a swift or the relatively quick and straightforward process, ideal for mixer design refinement through trial and error process. Moreover, the mixers deliver consistent quality, providing a homogeneous mixture. However, a batch mixing presents a significant challenge in 3D concrete printing. Over the time, the material undergoes aging, leading to changing material characteristics during the printing process. This becomes critical for the surface bond between the deposited layers, as a concrete mixture hardens and exhibits a reduced diffusion at the interface. Even when employing an end effector to mitigate this issue, determining the appropriate chemical additive dosage for a material with non-linearly changing properties poses a significant challenge. The next mixing system is a continuous mixing. A continuous concrete mixer is a machine engineered for uninterrupted, ceaseless blending of concrete. As its name suggests, this mixer type functions continuously, allowing a consistent flow of dry materials into the mixing chamber or mixing system, coupled with a continuous water dosaging rate into the mixing chamber, where they are combined, blended, and discharged without halting the process. Unlike batch mixers, continuous mixers don't have distinct intervals between mixing cycles. Instead, they maintain a constant and ongoing mixing operation. For 3D concrete printing, continuous concrete mixers offer several advantages due to their ability to provide a consistent flow of concrete material. They play a crucial role in ensuring that the concrete used in the printing process maintains the necessary properties throughout the printing operation. This includes a consistent composition, suitable viscosity throughout the process, and requires structural integrity. Essentially, the printing material is less time sensitive, as each discharged material is effectively relatively new, enhancing adherence between both layers. Nevertheless, thorough pre-mixing of the dry materials is essential just right after the mix proportioning, unlike batch mixers that don't demand this particular step. Additionally, achieving precise control over parameters and mastering material handling is vital, particularly in the initial stages. Certainly, the continuous mixing process offers superior material property control, but often comes with higher price tag. Let's take a break at this point as we approach to the final video of this week, which will be focusing on the discussion about 1K or 1 component or 2K 2 component pump systems, closely linked to the application of the end effector, as I have highlighted a lot in the previous videos. Right then, I'll catch up with you shortly.